Welcome, my name is Matthew, and in this video we're going to talk about product to sum and sum to product formulas. And this is going to be a short section. I'm going to work through a couple of examples for you where we're going from sum to product and back from product to sum. We'll try a few different trig functions, and then I think you're going to be well on your way on this one. So let's do some examples. The first thing we need to do is familiarize ourselves with these formulas. So just take a quick look through these and realize that on the left-hand side, we have a product, and on the right-hand side, we have a sum, and the sum is actually a sum or a difference. We're calling it a sum just sort of generically between those pairs of trig functions on the right-hand side of the equal sign. And don't forget about those coefficients of 1/2 that are outside of those square brackets. If we really needed to evaluate and simmer these down to a specific value, we would need to apply that multiplication by 1/2. All right, let's try some examples. So the first one says that we're to use the appropriate formula to express each product as a sum or difference. And first we've got the sine of an angle measure times the cosine of an angle measure. These are unusual angle measures. I'm even going to go in here, and if you were taking a test or you had jotted these down on scratch paper because you were doing these for homework, don't hesitate to put parentheses around those so that they're more apparent to you as an angle measure. And let's see, we're looking at sine times cosine, so I go up to my blue box there that has my formulas, and I'm also going to take a quick second to locate these sum and difference formulas. It's not those, it's not those. Oh, product to sum, here they are. It's the second group from the bottom on my formula sheet, so if you're one of my students and you're using this formula sheet, be using it. If you're not one of my students and you don't have that formula sheet, I think it was in the first video from this chapter, I put the PDF up on the screen so you could do some screenshots and sort of merge those couple of images together and create your own version of the same formula sheet that we're using. So whether you're looking at your printed notes or your formula sheet, I'm looking at sine times cosine. That is, does order really matter? I mean, the third one says, let's even just go in and number these. First one, second one, third one, fourth one. The third one says sine times cosine. The next one says cosine times sine. What's the difference? Couldn't I just take these and change their order? Yes, you could. Does that really change the problem? Well, it changes alpha and beta. At the moment, if we're going to use formula number 3, alpha is 2x and beta is 3x, which in here doesn't matter because we're adding them together. 2x plus 3x is going to be 5x. But in here, 2x minus 3x is going to be negative x. If you swap these two functions around, if you write it as cosine times sine and your alpha and beta change, this is still going to be a 5x, but then this would become a positive x. So it does make a difference. The alpha minus beta would become a positive 5x instead of a positive x instead of a negative x. And if we swapped these around and made it cosine times sine, then we would be using this one. Well, these arguments wouldn't change. There's still alpha plus beta and alpha minus beta, but this minus sign would change right here. Would that compensate for the fact that alpha minus beta has become a positive x instead of a negative x? The answer is yes, because the sine function is an odd function. That negative would come out, impact this plus sign, change it to a minus sign, and the two solutions would be equivalent. All right, we've just gone down the rabbit hole and we haven't even started working on the first problem yet, hardly. So let's get to work. So again, this is going to be my alpha value. This will be beta. If you want to label those, my alphas are terrible. My betas are, that was even worse maybe. And I'm going to set this equal to 1/2, and I am going to use the third of these formulas, so it's 1/2 times the sine of 2x plus 3x plus the sine of 2x minus 3x. If I were doing this on a quiz or a test, maybe I wouldn't actually write all of those out. I would just write down the solutions. But for the purposes of being introduced to this material, I'm writing it all out. There's the 1/2 again, and now I have a sine 5x plus sine of negative x. Now, is it possible that you could be working on a multiple choice test or even in a homework assignment and this is not one of the options? Absolutely. That could happen. Realize that this is a viable final answer, and if you want to put a box around it, you can. I'm also going to, however, put another version of this answer. I'm going to write it as 1/2 sine, still the 5x, but I'm going to write it as minus sine of positive x. Close my square brackets. That's another version of the same answer. Remember, I just said a moment ago that sine is an odd function. Therefore, we could take the negative from inside of that sine function where it says negative x. We could bring it outside of the sine function, which would make it a minus sine. So there's the minus, and the x would become positive. So these two statements are equivalent because sine is an odd function. Don't just gloss over that. Recall that information. We do still need to know the properties of our even and odd functions, whether we're in an algebra class or as we are here in a trig class, in order to make little modifications like this one. Take the time to figure out some way, in your own words, to articulate the fact that these two statements are equivalent because sine is an odd function. Maybe it's as simple as just writing that. We've got cosine sine next. The 5x over 2 would be your alpha value. The x over 2 would be your beta value. And I would use, we've got cosine times sine, so I would use formula number 4. Let's go ahead and do this one. There are a couple of other examples down here. I don't want to do one of all of these, but let's go ahead and do one more. I will switch colors. Let's do this next one in red. Block that off. And so this is cosine sine. We said it's number 4. And so we have 1/2 times, and let's expedite this process a little bit. Let's do the arithmetic. So alpha plus beta is going to give us 6x over 2. That's the sine. Oh, I'm a big fan of showing all my work. I can't do it. I've got to write it all out. We've got 5x over 2 plus x over 2 minus the sine of 5x over 2 minus x over 2. Close with this big square bracket. And then I'm going to keep working my way from left to right because I'm a little short on space. Let's go over here and write 1/2 square bracket sine. And now I'm going to add and simplify. This is 6x over 2, which reduces to 3x. There's my minus sign, and then sine of 5x over 2 minus x over 2 is 4x over 2, which simplifies to x over 2. Simplifies to 2x. This is the only version of the final answer I think that we need to consider. Could I change this to a plus sign and this to a negative 2x? Yes, I could. For the sole purpose of making my argument 2x into a negative 2x, why do I want that to be a negative 2x? I don't want it to be. Are there circumstances where maybe you would want it to be? Sure. This isn't one of those, so let's just leave it like this. Now, we're about to change. At the moment, we're looking at product to sum. Now we're going to look at sum to product. Are we not simply going to take the right and left-hand sides of these equations and swap them? We're not. Well, let's go down and have a look. These are substantially different. I'm seeing fractions on the right-hand side of these equations as the arguments, alpha plus beta over 2, alpha minus beta over 2 on the product side. And we definitely did not have that previously. So having this different version of these equations as we go from sum to product, I think is beneficial. And I'm glancing at my formula sheet to make sure. And yes, indeed, this is the last group of formulas on my formula sheet. So I know that that's where they are when I get to use my formula sheet on my test. So let's try one of these. I'll keep this all on the screen. There we go. And I have a sum of sine functions, sine plus sine. So I'm looking up here at the first of my formulas. My alpha value is the 3x over 2. My beta value is the x over 2. And I'm going to plug those in on the right-hand side of that formula. So let's write equals 2 times the sine of, and if you'd like, you could put parentheses here because we're going to have a lot of fractions going on here. We've got the 3x over 2 as the alpha value, plus the x over 2 as the beta value, and then we have to divide all of that by 2, close, times the cosine of our alpha value, again, 3x over 2, this time minus our beta value of x over 2, all divided by 2. And I think that's it. All we have to do is clean this up. I would typically do this all in one motion. If you would like to write this out in 2 steps, you can. If you want to pause this and work it out for yourself, and then push play and see if you get what I get, that's not a bad idea either. So in the big numerator here, I've got 3x over 2 plus x over 2. Those are already common denominators, which gives me 4x over 2. And then that's over 2 again. So I have 4x over 2 over 2. And then the cosine of 2x over 2 all over 2. So we do still need to know how to reckon with multiple fractions like this. Let's keep that leading coefficient of 2. The sine function is still there. And 4x divided by 2 is 2x. So that takes care of this part of the process. And then the 2x divided by this 2 reduces to just an x. So this is the sine of x, and then times the cosine of, I'm going to take the 2x and divide it by 2, which makes it into an x. And then this 2 still needs to happen, that division by 2. So this argument is x over 2. And that is our final answer. We can't distribute this leading coefficient multiple by 2. That 2 cannot multiply into those arguments. So we're going to leave it right where it is and put our box around that as a final answer. And this process is very similar. It's very similar to the previous one that we did. This is your alpha value, pi over 2, or sorry, pi over 12. Your beta value is the 5 pi over 12. It's cosine minus cosine, so you will plug those into the right-hand side of the fourth equation. Your alpha and beta values, do a little bit of arithmetic, a little simplifying of fractions, and you should find yourself a final answer very quickly. Let's see if I can just... You'll never believe who's here. Why don't you just... Can you just be here and relax? Maybe that's your... Not your good side. That's your good side. There you go. Let's see. This is cosine minus cosine. So let's slide that up a little bit. So alpha minus beta. Oh, the first one's alpha plus beta. So that is going to be 6 pi over 12, which will reduce to pi over 2. That has to be divided by 2 again, so it'll be an argument of pi over 4 inside of the first sine function on the right-hand side. And then the second one is alpha minus beta. So that's pi over 12 minus 5 pi over 12, which is negative 4 pi over 12, which reduces to negative pi over 3, which gets divided by 2 again, becoming negative pi over 6. So this should turn out to equal negative 2 times the sine of I think I said pi over 4 because it was 6 pi over 12, pi over 2, pi over 4, yes. And then this turns out to be the sine of, I said negative pi over 4, which was negative pi over 3, which becomes negative pi over 2. Our nails are really sharp. Negative pi over 3, negative pi over 6. Now, remember, we've talked about this a couple times already, that the sine is an odd function, which means that the negative that's inside there with the pi over 6 could be sort of factored out. It's not really being factored out, but it's a property of odd functions. So what I'm going to do is I'm going to take this negative sign right here and bring it all the way out front, which causes it to interact with this negative sign, and they cancel each other out, giving me a final answer of 2 times the sine of pi over 4 times the sine of now positive pi over 6. And the thing we really want to note, other than the fact that I can't write the number 6, there we go, is that this is now positive. And oh, Sophie's tired already from all this math. It's possible in this particular case you could be asked to go all the way with this because you know very well how to evaluate the sine of pi over 4 and the sine of pi over 6, so you could come up with a numerical answer for this problem. Let's knock that out real quick. Equals 2 times the sine of pi over 4 is root 2 over 2. The sine of pi over 6 is, oh, that's just 1/2. Oh. So this 2 and this 2 cancel, leaving us with a final answer of root 2 over 2. I don't know if you're going to be asked to find a numerical answer to any of these problems, but in this particular case, that was pretty easy to do. And the last question in this section is asking us to verify an identity. And as I have encouraged you to do before, I typically start with the more complicated side of the equation and try to wrestle with that and turn it into the less complicated looking side. I think that on the left-hand side, I think that's the more complicated one. And the only reason why I'm tending toward that one is, granted, I've seen this problem before, but I know that the section that I'm in is the section that works with product to sum and sum to product. And sum means addition, but it could also mean subtraction. And on the left-hand side in the numerator, I see sine minus sine, which is the second of my sum to product formulas. And in the denominator, I see cosine minus cosine, which is the fourth of my sum to product formulas. And on the right-hand side of those sum to product formulas, I end up with a sine function times a cosine function with some division by 2 happening. And on the right-hand side of this equation, I've got a negative cotan of x plus y with some division by 2 happening. So maybe, just maybe, this is going to work out. My other option would be on the right-hand side, would be to try to work with the cotangent function that has that division by 2 in it using a half-angle identity. And if you go back and look at your half-angle formula for tangent, on our formula sheet it says the tangent of alpha over 2. It's almost right in the middle of the page. It's equal to plus or minus the square root of 1 minus cosine alpha over 1 plus cosine alpha. I don't think I want to try to take this argument from a cotangent function and work it into that as my choice of formula in order to verify the identity. So let's wrestle with the left-hand side of this thing a little bit. Sine minus sine. Okay, I'm going to the bottom of my page, sum to product formulas, sine alpha minus sine beta. Okay, so left-hand side is going to be a big fraction, and it's equal to 2 times the sine of a fraction, and it's alpha, which is x in this case, minus beta, which is y, all divided by 2, times the cosine of alpha plus beta, So that's going to be x plus y all divided by 2. And then the denominator is the cosine minus cosine, which is the fourth of my sum to product formulas. And on the right-hand side of that formula, it says -2 times the sine of alpha plus beta, which is x plus y in this problem, divided by 2, times the sine of alpha minus beta, which in this problem is x minus y. Alpha minus beta, yep, okay, divided by 2, very good. And now we have to try to simplify this fraction. I'm going to put my equal sign here because that equal sign is that equal sign. So I'm just bringing the left-hand side of this equation down and hoping I can make the left-hand side look identical to the right-hand side. So what could I do next? Well, the 2 divided by -2 is equal to -1, which I like because in front of the cotangent function, I've got a multiple of -1. That's a negative leading coefficient. So that makes me happy. And then the other thing that I'm seeing is that the sine of x minus y over 2 is a factor in my numerator, and it has an identical factor in the denominator, so those can cancel. And now I think I'm just going to rewrite what I have remaining. Zoom this in, see if I can move it over a little. Yep, that'll stay there, good. So, well, maybe it'll stay. So the 2 over -2 becomes negative, a -1 really. And then here's my division symbol, or my fraction bar. In the numerator, I still had a cosine of x plus y over 2. In the denominator, I have a sine of, the same argument, x plus y over 2. Equals, there's that same equal sign coming along. And you should know by this point, one of our quotient identities, sine divided by cosine equals tangent, the reciprocal of that quotient identity says that cosine divided by sine equals cotangent. So if you want to put a little note over to the right-hand side maybe, by quotient identity, and maybe you want to write cosine over sine equals cotangent. You could put yourself a little additional note as a reminder over there that sine divided by cosine is equal to tangent. However thorough you need those supplemental notes to be, you do that, you make that decision. But on the left-hand side of this equation, we are in good shape. I'm going to bring the negative sign down. Cosine divided by sine makes cotangent. And the argument is there, x plus y divided by 2, close, equals, it does indeed equal the right-hand side, that's that same equal sign, and I celebrate by putting my box there and shading it in. That's my QED, quod erat demonstrandum. It has been shown. If this pencil were less expensive, I would drop it, but can't afford to do that, so I'm just going to call that one a win and get out of here so that I can move over to the next section, which is the last section in the chapter of the book that I'm working with. I don't even know what I'm doing in that section. I'm going to find out when I get there. If you would like to find out also, follow me over there. There should be a box right down there that appears with a link that'll take you right to that next video. Join me there. Thanks so much. See ya.